Hello, guys.
Hello.
Hey,
Do you have any questions?
I have a question about my about classes. I sent you an email,
Right,
and I think I only have 3 classes left, like 9 credits left after this semester.
right.
So you said I still need 2 semesters.
Yeah, and this is because of the capstone project. I explained in the email, but you said you're working. Um,
Yes.
if it's if your job role is data analytics, then you can use that to waive 3 credit hours, and
Uh,
we will need to approve it. But if your job role is highly relevant, then it won't be a problem.
okay. Can you would it be the same steps that I did last time during the summer? You remember when I did the job I had, and then I got credits for like the special problems course. Would it be like
Okay.
that same?
Yeah. So it's the same job.
Yes.
You might want to show because you already waived some credits. You you need to show more proof, I guess.
All
Um,
right.
is it paid position?
Yes.
Um, I guess formal job letter. I mean job offer,
Uh-huh.
and if it's paid position, then pay stubs
Okay.
over,
Checks.
yeah,
All right.
from ever since, I mean, for the past 4 months, I think.
For the past 4 months, I'm so glad I kept them. I forgot them. Does the
I
amount
got,
matter?
huh?
Does the amount matter?
What what does it mean?
The amount on the check, does that matter?
The
Would that,
amount of check. Well,
yeah, but
it
would that determine if I get credit or not? If it's like
I
high
guess that
amount
might
or
be related. I mean, compensation for work,
hmm
it's got to be substantial, right? It's got to be supporting um your life expenses.
yeah, yeah, it is. It is.
But I can't guarantee because you use the same job position in the summer already. You know,
Why can't I take both of those classes in the same semester?
that's just the design. Because once based on the design of the degree, one semester you cannot learn much. It's project based. It's highly experiential. It's team based. In one semester, it's similar to a course. Um, for a highly structured course, you can learn a lot. You can continue the learning after the course by reviewing the material. But in a real life project, sometimes project take long to progress. So in one semester, there is not enough to be learned. That's why.
I should have
But,
taken I should have taken the first semester of that class this semester then, so I could have graduated next
but
semester.
you need this course to take that. So,
Mm,
you know, uh, one needs to finish all the core courses before she can take the practicum. It's really for the benefits of your future. If if you didn't get enough training, you get out and then you make mistakes. That's even worse, right?
okay, okay, all right.
Yeah, but for the second, I mean, for the last semester, if you only have to take that one, the second part of uh, practicum,
Practicium,
practicum.
practicum.
This is capstone. Yeah, capstone practicum. You can, you do not have to be here. It can be done remotely. teamwork can be remote. You can remotely join in. So even if you are not here, and better if you are here, but you can, work on this part-time, definitely.
Uh-huh.
You can have a full-time job as long as
Uh-huh.
you have some flexibility.
I'm gonna see if I can get credit for it with my current job. See if we can make the exception. Or I'll submit all the paperwork and the pay stubs and everything.
Okay, yeah, send it to me and I'll let you know.
Okay, thank you.
Mm-hmm. Hello, everybody. How are you?
Good.
Good.
Yeah. So today will be more interactive. I'll do more demos and some discussions, mostly demos, but demo in the sense of interactively, and think with me along the side, because this kind of exercise benefits your understanding. It's hard to talk about these really, and so that you know how to use these through practicing and making mistakes and doing experiments. So that's one. I'm mostly focusing on regular expression today. I have a little bit slides to walk through, but mostly regular expression to deal with specific problems and patterns with the textual data, unstructured data. So that's a point. Okay. Looks like we have enough people here. Okay. Shall we start? So I uploaded the slides and the demo Jupyter Notebook. Download it, launch the Jupyter Notebook with me, and we can walk through the examples. And also, think with me as I do the demo, as I walk through the problems. Let's see. Hold on.
Professor?
Yeah?
Yeah, I could not find BZAN6357 Yelp dataset in the Blackboard.
But that data will be uploaded later, but today's exercises will not deal with that.
Sure, sir.
Will we?
I don't know.
I thought, let's see. Oh, okay. So I included a few, did I? Wait, hold on. A few temporary codes. You can ignore that for now.
Sure, sir.
Yeah, it will be uploaded once I finish the all the demos, all the videos. But it will be there. I used some text data from this data set, but I mostly copy pasted into the Jupyter Notebook without having you to read the data files. So for now, you can delete that 2 cells that refers to the DF9 and the Yelp data set. Anything else?
No, Professor.
Okay, great. Hold on 1 second. All right, share my screen. A little bit of slides to go through. So this is not the agenda for today. Today we will focus on this. I'll talk a little bit about that and mostly this. use regular expressions. Are you at all familiar with regular expressions? Anybody? It's not
Yes.
limited to Python.
Yes. The
Uh,
pattern matching,
which language did you use it?
Python and Scala.
Python?
And Scala.
Scholar?
Yeah, Scala.
Scala? A language I don't know. Is that for data science?
Yes, Spark. Spark,
Oh,
you can Python and Scala.
Spark. You see, yeah. Um, so you do a lot of coding in Spark.
Yes, I used to.
Mm-hmm. Great.
I think
Yeah.
SQL also has regular expression, right?
Yeah.
SQL, it has the capability. It's doubtful that you use a lot. Do you use a lot?
No, not very frequently, but I know that you can use regular expressions in SQL.
Yeah. Advanced queries, I guess. Yeah. Mm-hmm. And most other languages, even, let's see, and similar functions like regular expression, even if you don't code, is that the wildcard in lots of the search functions, like in Word, Microsoft Word, when you use wildcard, it's a little bit similar to regular expression, although not as complex. But I find it very helpful. You know, you can search for hidden symbols by using the wildcard. You are not restricted to the visible letters and numbers, but those are quite advanced functions. So regular expression in other languages, yeah, Java, yeah, C definitely. And in the next few weeks, I'll also talk about mostly focus on Yelp data, you know, how the data was collected. I'm not going to go to in depth of how the data is collected, but I'll talk about the workflow because I scrape data from various websites. Different websites have different challenges, but overall the tool set are similar. And they evolve, you know, along the time. And I can share a little bit of tricks in terms of, you know, sometimes the website is, I guess, more secure or smarter, like Yelp. They have smarter design elements that can prevent over scraping. So I had to deal with that. Right, I'll share a little bit about that, and then I will talk about after cleaning the data. I will talk about prepare the data for model for mostly quantitative modeling. For text mining, you would have to do these in some step. You will do these sooner or later, regardless of what kind of analysis do you do. As long as it's machine learning, you'll have to quantify the information in the texts, and these are the standard procedure to prepare the data. And then I will talk about one model in depth, LDA, which is based on bag of word model. If you wonder how to pronounce this word, Dirichlet, it's a German word. Latent Dirichlet allocation, LDA, is much widely known. If you say LDA, people will know what you mean. All right, so that's the agenda for this module, but today we'll talk about these two. Unstructured data. So let's see. So unstructured data means any data that is not structured. So what does a structured data mean to you? We have been dealing with mostly 98% structured data so far in this course. So how would you characterize structured? What does it mean? Anybody?
There's a schema. Each attribute has a data type.
Each data has a
A data with
type.
without variables.
Variables?
With label.
Without labels.
With labels, what do you mean, labels?
I mean, a data set without labels or variables.
So, you mean as long as the variable has a label?
Yeah. Yes, Professor.
Like gender, age,
Yep.
things like that?
Yeah.
That's structured.
Yeah, that's structured.
Are the data are formatted as rows and columns?
Rows and columns. So like a spreadsheet structure.
Yes.
Right. I think of the sense of variable becomes closer to what's referred to as structured. And this corresponds to the rows and columns sense. When you have the spreadsheet format, and typically we say each column is a variable, and by the very definition of the variable, we assume that the data is clean. Of course, there are data set that is put together in a wrongful way. So that is unclean data, or that is unprepared data set. By prepared data set or clean data set, because we'll assume that the variables are defined, then in this case, each variable represent in most cases a unique piece of information for a case in a role. So that's good. But there are exceptions, of course. It does not prevent a column to have very long text strings. And, I think this falls in the middle of between cleaned or prepared and unprepared data. Prepared data sometimes also has these columns, like notes. You can, notes are still included in this data set because there might be useful information in the notes. And by doing simple query, you might be able to create all kinds of dummy variables to record whether or not a piece of information is, is present, is found in this long string, even though this piece of information tells a very, detailed aspect of it. But this can sometimes be useful in modeling because it's another variable, potentially. So notes are included, and then this variable or this column would say this is barely a variable because there are many possibilities here. But this column is unstructured in some sense, and it's hard at that stage. It's hard to put any more structure to this column. So this column is simply retained and included in the data for hopes that it might be, there are ways to put more structures to this column. So before text mining become popular and become easier to do, this is what people have been doing in dealing with the possibility that there might be information in these columns. Databases sometimes might not include these because it's just, it takes a lot of space in the hard drive without generating much value, right? I don't have industry experience working on databases in a company, so I don't know the best practices. Does anyone have MI's professional experience where you mostly focus on database design or maintenance? What's the best practice for possibly storing notes or comments that might have a long string of characters, but you have to deal with that in a different way instead of simply storing it as a column? Anybody want to share? Not much experience with data?
No experience. I usually use Excel, so I don't have any experience with this at work.
There are unstructured database like MongoDB.
Yeah.
So you don't need to define a column.
Right. That's different. I'm talking about
they're on the story, that kind of information of data.
Database, it's a challenge, Yeah. So things like these, in my research, I will see these columns once in a while, and when I collect data, I put these in the data set, and I typically don't have to construct a database because the scale of data collection from the internet is not as complex, so it doesn't require to put together a database. So anyway, for the bulk of the unstructured data that we're talking about here, we're mostly talking about the text data. It doesn't have to be stored in a column. It can be a text document per se, describing something that we also have information about. It can be articles, it can be documents or notes, doctor's notes, or movie reviews. Movie reviews can be long, longer than Yelp reviews. Some Yelp reviews are also long. Amazon reviews can be long, but typically not as long as movie reviews. So that's why in the book, in the PML book, the example that's shown is the movie reviews. The reviews can be long, but they still put that in a column. So that's a giant column in some cases. But there are other types of unstructured data. Unstructured data is not restricted to a text column or documents, but for the most part, unstructured data can be, other examples can be network data. And there are ways to convert those data into a structural format and apply social network analysis. But there are other kinds of network data that may not be appropriate for social network analysis. And so those are not the focus of our discussion here. But the reason that we focus on text columns is because it's already in the column. It's describing unique, instances of a concept that we are interested in, and there is potential rich information inside that column that hopefully we can put into a structure. So this makes the text mining highly relevant. We are essentially dealing with the text and try to mine the text data. So that's text mining. Or text mining is part of the natural language processing. It's not that natural language processing is always machine learning or text mining. It can be purely linguistic related analysis. So that's a bigger domain. Have you been doing anything with text mining before? No? Text mining, you might have taken some courses that I don't know, in business maybe may not be likely, but in other domains like engineering, have you done anything, projects, exercises that are text mining? No? A popular example, go ahead.
No, I was just saying, like, I haven't had any experience with that yet.
Mm-hmm. A popular example for data mining is sentiment analysis, if you heard about that term. So basically what it means is that if there is a value to quantify the sentiment, typically positive or negative, or you can have different levels of positivity. You can have highly positive, neutral, negative, and highly negative, or extremely positive, negative. You can have different levels, but that concept is sentiment. So if there is value to assign a level to a piece of text about the sentiment about something, then you can try to find ways to correlate the textual features with that sentiment and learn how to predict new texts, how to predict the sentiment, or ultimately how to recover the sentiment of the author of the text. In Twitter analysis, there has been research on how does sentiment of the tweets affect stock market movement, right? But when you see the Twitter, it doesn't give you a measure of sentiment. You can read it, then as a human, we know the sentiment. Is this person positive or is this person negative about, or optimistic or pessimistic about the economy or about a company, and you can infer it. But machines don't have that capability. We need to. It needs an algorithm to systematically infer the sentiment. Then we can use supervised learning to guide the machine to classify or predict sentiment. To use machine learning or supervised machine learning, we need to have variables. We cannot put in a column of text. That doesn't work. It has to be some quantitative measures of the text. So text features or word embeddings are what have been the most common or effective solutions to these. So when I say text mining, think about it. I already mentioned something here, but when you hear the term, when you think about text mining, it's a bunch of methods. Text mining is a body of literature, it's a domain, and it's a group of methods. Do you think text mining is supervised learning or unsupervised learning?
Supervised learning.
In what sense?
The actual text needs to have some meaning behind it, and the programmer would give it that meaning. Like a certain word is positive or negative, the programmer would inherently code that in the words.
Yeah, that's in the sense of sentiment analysis. Yes, it's supervised learning. Does it always have to be supervised learning?
I don't think so. It can be either supervised learning or unsupervised learning. Depends on your application and problem.
Right. Can you think of an example for unsupervised?
In the area of, let's say, handwriting recognition.
Handwriting recognition.
Yeah, Prof. I think that's a good example of unsupervised machine learning.
So what's the problem?
I've read few research papers where with the help of image processing, you try to recognize a handwritten text and try to convert it into good formatted text document. So in that case, the text need not have any necessary meaning. It's all about each individual alphabet and how good your algorithm, your model is able to recognize individual character.
You mean those letters?
Yeah, letters. Yeah.
Okay, so you have a piece of paper. You have a handwritten. It's a handwritten material,
Yes.
and you need to recognize the letters on the paper.
Right.
Somebody's smiling. I don't know why. Anyway, sorry, back to your example. So if it's unsupervised learning, then the algorithm will come up with a way to segment, I guess, a way to separate the letters. But if for those letters to be recognized and meaningful, there's a sense of correctness, right? Whether or not the recognition is correct. So I think in the case of handwritten letter recognition, it's a supervised learning where machines are trained on recognizing the handwriting patterns and to classify each letter as a correct letter. So this is more of a handwriting recognition problem. It's actually quite supervised. It's quite like supervised learning, in fact. And the data, the data is a picture actually, right?
Yeah.
The pixels are converted, and this is the way that
That's where I got wrong. Yeah.
converted into the pixel RGB values mostly. So in that sense, it becomes structured, but initially it's unstructured, and because it's a picture. but using the pixels, it's converted to unstructured. I mean, it's converted to structured. Interesting. So I think even though, you know, handwriting recognition is more of a supervised learning, but you can think a little bit broader to think of the documents instead of the letters. So if you have a large quantity of articles and you want to develop a search engine, right? Using keywords or using whatever, using sentences to try to find the best match, or to try to rank the documents in the inverse order of relevance. That's a great example of unsupervised learning, because even for humans, there is no right answer, right? You know, you have a library, and if your purpose is to find the best article to read to understand something, there is no correct answer as to this article is the one and the only one that you need. No, you typically, to learn about a subject, you typically need a list of literatures, and they are a complementary set. One doesn't replace all the others, right? So in this case, you need an algorithm to quantify the relevance between a search term and all of the documents, right? And once you have that quantity, you rank the documents in the inverse order, and you can identify a small set of literatures to recommend. You know, that's basically what Google does, but the underlying algorithm might be very complex, but it's an example of text mining and document analysis specifically, and an algorithm to rank the relevancy of the documents in terms of a keyword. Does that make sense?
Professor, expanding on that, is target marketing also a form of unsupervised learning?
Targeted marketing, in what sense?
In like whenever there's an algorithm for YouTube or like on Google, Instagram, or all these different posts, because usually you see I guess maybe not, because it's based on your implied search results. But not 100%. Because autocomplete in Google search, I was trying to like relate that to your search engine with the text documents, and then targeted marketing, not sure.
Mm-hmm. Yeah. Let's talk a little bit about that. So I think you meant to say recommendation agent mostly. That's
Yeah.
the term in the literature. You know, things like Amazon. How does Amazon recommend a product? YouTube, as well as many others, TikTok, even, because there are potentially an infinite set of alternatives to recommend. Which one do you recommend, right? There are different algorithms to tackle this problem, but in any case, recommendation agent or recommendation like recommender system, the algorithm behind it is unsupervised learning, definitely, because there's no correct answer, and there is a flexible. I mean, right. Basically, there's no correct answer. There's no correct solution, right? There's no sense of correctness. There's only better and worse. So so that's unsupervised. There may not be text involved. You could or couldn't. You may or may not involve text mining here, but on its own, it's unsupervised learning. So you recommending videos involves some more challenges because it's video and tons of data. If you want to convert the pictures into pixels, it's too much information. So you may want to leverage the comments for the video or descriptions and comments for the videos to help with the recommendation systems. So that is, so the text, how to extract information from the texts becomes a part of the text mining task. Yeah, in the broader problem. So that's a great example here.
And on the flip side, like apparently I watch a lot of TV, but is when there's on Netflix or on all these streaming services, when they skip the intro, is that supervised learning? Because I'm guessing that's pattern recognition and it has to have a specific amount associated with it.
You mean, how does Netflix do that?
Yeah.
Right. That part I'm not familiar, but ultimately, you can imagine that might be, although this is quite unlikely. There might be a worker behind it, right? You can do it manually, definitely, right? And it all comes down to a pattern. Manual worker can do this very, very well.
Yeah.
Right. As long as a series of videos are identified that follow the same pattern, then always skip 20 seconds. That can be done quite easily. But on the scale of the materials, on Netflix, it becomes infeasible to use manual workers. But who knows? I don't know this part of the industry. I don't know how they do that. But if you were to do it using machine learning, supervised learning will not be helpful here, because every show is different. There's no way you can find a universal pattern other than there is certain X number of seconds that you need to skip. But which part, how do you use one show doesn't help the other. So I think using examples to train machines won't work. So that's why supervised learning may not work to me. So they may be done using unsupervised learning. Comments? Comments? No?
No.
Yeah. So interesting question. I think it will be very interesting to work, in these companies to solve these problems, and also to identify problems to solve. I mean, that's the tougher part, but that's got to be very interesting. So you need to analyze the viewer behavior before, and you are a viewer. Obviously, you are in an advantage. But there could be many other problems that you can find a solution using machine learning. They're very exciting. But okay, so here, so text mining can be supervised and unsupervised. Definitely, it can also be reinforcement learning. Translations and human human-machine interactions, natural language understanding, to train a machine that can improve on itself by assigning rewards and punishment. You can train a model that improves over time. So that's the philosophy of reinforcement learning. So things related to here, using Yelp reviews as an example. So let's think about it. This is a part of the data set. I extracted 3 columns here. There's an ID column. This ID is for the review ID. Imagine that each review has an ID. Each review is unique. A review a customer review always has some kind of rating assigned to it, right? When you write a review, you have to assign a star rating from 1 to 5 on Yelp, as well as on most the other websites. And you write review, you may post some pictures. You may also make some other selections on, I guess, on other websites. On Yelp, that's pretty much it. There are other columns I collected, but here I only show 3 columns. So if the problem here is for you to train a machine learning algorithm, supervised learning, to predict star ratings or classify star ratings, because there are only 5 possibilities, what structured information do you need or can you use? What structured information are available? Structured information include numeric variables that are displayed on a website that you can collect, or some piece of information that follow a pattern in the texts that you may easily find out. You can search the text of each review and search for a specific word. Then you can easily make a binary variable to indicate whether a word is like, delicious or something like that, those words. So that's identifiable quality information. So what of these information do you think you need to be able to predict review rating, right? If you go to a restaurant, I don't know which cuisine is your favorite. In Houston, we have all kinds of cuisines, right? If you imagine that you give a rating, there must be some reason that you assign 4-star, 5-star, or 1-star. Too bad. And think about those information, think about those scenarios, or think about your own experiences, and think about if those information are already available on Yelp. Maybe that's something that you do as a reviewer. You make a selection, or maybe it's somewhere on the website that you can extract. What are those? Ways to think about this is a review. A review is an event. A reviewer writes a review, assign a star to a restaurant, or a business. So you have a business or restaurant as an object. You have review, and also you have those things that influence your review for this business. Mostly it's the dish, it's the food, or something else, right? About that transaction. So let's do a breakout room And think about what information will you need, these two questions, and put them into categories, give them a name, and see how what you can get. Right, let's make teams of 5. Let's talk a little bit about, you know, how much you can come up with in terms of predicting review stars. Four, 1, 2, 3, 4, 5. 4. Okay. Hold on. 5 minutes. Let's go.
In order to figure out
Professor, could you repeat the questions? We kind of missed the end goal.
Yeah, I thought Korean was talking.
I was trying to remember the questions that you had on the list. It was like what variables we would need in order to be able to predict.
Right. Think about the review ratings. Each review has a rating. A rating is 1 to 5 stars.
Yeah.
If you were to develop a supervised learning model to predict the rating, what variables or what information do you think you can extract from the website that's already available?
To
Or
extract from the
information do you need?
website. To extract from the website, that's going to be difficult because I don't put very much stuff on Yelp.
Mm-hmm.
But like, can't we just the historical implied data for the ratings for each, the individual restaurants or whatever, businesses, you can get that, and then keywords within the reviews for that rating so that you can associate like the kind of problem that might be causing each
Like
review.
what? Like typical factors that
might influence the rating. Yeah.
The rating, yeah.
So you could go, what restaurants have they reviewed previously? What are the genres or types of food that they've reviewed previously? How many reviews have they done previously? Are they all 5 stars, or do they only review if they're negative?
Yeah.
Yeah. Average rating can predict to some extent, right? But average rating doesn't tell a whole lot.
Can you do their search history? I mean, if they've been looking at different restaurants and then they finally land on one, so you can kind of see what they were looking for.
Oh, you mean the choice set, kind of, for this person?
Yeah, like, so if I was going on Yelp and I was like, hey, I want Indian food tonight, what Indian restaurants are near me? And I look at like 7 different Indian restaurants, and then, 3 hours later, then I go and review one of the Indian restaurants. So you can get that historical data.
That I think that's challenge. That's a challenge because it's hard to trace it. But I think you're touching on something, or at least you're describing something that rings a bell to me. I think you're describing a sort of a choice set that this customer considered before he or she decides to patronize this restaurant. And what does that do then? To me, that sets up an expectation for the current sort of experience. And this is so-called prior experience. the experience, or not prior expectation. You know, how much you expect from going to this restaurant will have some saying about how much you're satisfied. And the star
Yeah.
rate is how much you're satisfied, right?
Yeah, because there is a lot of like, if you go and read a bunch of good reviews and then you go in and it was not 5-star for you,
Yeah.
but then your
Right.
hopes are, crashed. And
Yeah, that's
I think like stemming off of what Corinne just said, I think it should be like you're taking, if the person has historical ratings, if they've been an active part, then again, like it would be a keyword search to kind of recognize their ratings and then the reviews, the actual factors that are implementing those ratings, and compare it with other users and their reviews and their sort of like how what factors affected their rating at that specific location, and then maybe you associate that and kind of come up with like an 85% chance that this person, based on how it matches, will rate this restaurant at a certain threshold, something like that.
Great. And there are only 10 seconds, 1 second. All right, is everybody back? Can you all hear me?
yes.
Yes.
Yes, Professor.
Yeah. Okay. I was in one of the group. It was kind of an interesting discussion. It might be. I mean, it goes all kinds of directions. So let me hear what other groups have talked about. Anybody would like to talk a little about what your group discussed?
Our group said that if a review has words like phenomenal or amazing or very positive, enthusiastic words, the likelihood of a 5-star rating is increased. So that would be a good predictor in finding out if a review is 5 stars or not.
So that's a review text. But how would you, so it's a list of words, right? And do they have different, I guess, sentiment levels? Will you assign different sentiment levels?
Yeah.
You know, is fantastic better than perfect, or, you know, some other way? How would you go about, or maybe you only use a binary variable to log any of a set of predetermined words, I guess.
I'm pretty sure there'd be some type of API or a library in Python that already has sentiment words with the sentiment analysis already matched on a conceptual level.
Okay, so that's one kind of information that you can extract. Anything else? Information that's already structured on a website, and information that may not be displayed on a website, but conceptually there should be a way to structure it. Anything else?
We also suggested to count the number of positive and negative words that we can find in a comment.
So in the same logic, right? The positive words and negative words, I guess. So, right, a comprehensive review will touch on several aspects. Some of them the restaurant does well, others, the restaurant didn't do as well, and you can have a sort of a balance of positive and negative words. So this is similar to when you have the posts on Reddit have positive and negative vote, or upvote and downvote, and you calculate the difference or a ratio or some kind of way to balance the two opposites. Yeah. So all of these are texts. So maybe I was misleading you, but so let me talk about what I have thought about. So an obvious information that is already quantified on Yelp for each business, although it's not from each and every review. It could be, but I think it is. It's collected from every review. Is the price level, right? The dollar sign. It's not as accurate as to the dollar, you know, to the unit of a dollar, but at least it gives you a tier that you know customers can use to estimate the per person charge, or you know, likely charge. Every reviewer is asked this question, you know, how would you rate the price level? Is the price level consistent with your experience? I think on Yelp as well as on other websites. So that's one thing. And price can affect star ratings to some extent. It's not straightforward. It doesn't mean that pricey restaurant gets poor ratings. Otherwise, you know, Yelp can't do any business. And that's not the nature of a review and behavior. Pricey restaurants attract a different group of people, right? If they have money, they won't be disappointed. If they have money and the food is, you know, the food is, I guess, fantastic, given the price level, the rating can be, you know, 5, right? But if the food is disappointing to the price level that it charges, then you can get very negative reviews. So that's one thing I can think of. For restaurants, there's a specific aspect of the business that carries a lot of weight to the ratings. It's hygiene level, right? Hygiene level is not quantified on Yelp. There's no specific field or indicator of the hygiene level of a restaurant. So consumers would have to read the reviews, would have to look at the pictures. The pictures don't tell a whole lot, but it does give you some information. But in terms of hygiene, mostly the problem happens in the kitchen, and customers will not typically have pictures about the kitchen and how the workers do their job. So you have much less information. I guess the only credible information that you can use from the pictures about the hygiene level is the certificate that the government issued for each of the restaurant. I guess that's meaningful, and you can only find out about those in the pictures that users upload. So that's one thing. Ideally, if there is a hygiene level indicator on Yelp for each of the restaurant, then you know the job of finding a perfect restaurant that you want to go to, the task becomes much easier, right? There's much less things to to worry about, to think about when you can rule out quite a few restaurants by setting a threshold, right? But hygiene level will definitely affect user ratings, if not every rating. I mean, hygiene may not be detected. Problems of you know, dirty kitchens or dirty dishes may not be detected in every transaction. But to me, it's a factor that I would consider. Another thing with restaurant is wait time, right? Wait time will affect how satisfied you are, regardless of the price level, right? And regardless of all the other factors that we talked about. So that's a business related, that's just restaurant specific factors that would affect at least how, how I would rate a restaurant. I would think about these factors when I write a review. But all of these information are potentially available in the texts, right? And things about hygiene, you can use simple keywords, simple bag of word method. Unclean, dirty, and these kind of words can indicate, but it can go beyond that. You can have a perfect illustration description of how dirty the store is, the restaurant is, or the dishes without mentioning dirty, the word. So there is potential for a machine learning model to be trained to identify these, linguistic, I guess, text bodies, linguistic features in the text that is relevant to how, the comments about the hygiene level, as well as wait time. There are also dish-related factors that will affect my review of a restaurant, such as portion size, right? You cannot find reliable information about portion size until you actually eat there. You could read about it in the review text. It will take a lot of time to discover that, and maybe not a lot of the reviews will mention this, or at least for the restaurant that you're looking. But portion size is at least one factor that could affect. And other things that you guys mentioned, cuisine type, flavor. Is the flavor good? Is it too salty? Is it too sweet? These things will have to be discovered based on experience. And another category is service related. How friendly is the waitress and waiters? What's the other aspects of the service, related to wait time as well. Environment, is it noisy? Is it too crowded in the store? What's the dining experiences, right? Many factors that you potentially can quantify. You can ask each reviewers to indicate all of these responses to these questions, but you can't put too many questions, otherwise you'll have much fewer reviews. Reviewers will not bother, contributing these informations. But so there's a tension between how much data to collect, and how to collect them. Makes sense, all of these? You probably haven't thought about it, but it can, these topics can be very deep as you go into it. There are many questions to be asked and few answers for those questions. So that's why this is one of the burgeoning areas of research in one case, as well as, provides potential for new entrepreneurship, right? You can discover business opportunities here. So that's the reason I talk about Yelp reviews. if text mining is done well, potentially all of those informations that I talked about can be extracted from the reviews. Some will fall under supervised learning, but a lot others will fall under the unsupervised learning methods. And just to, let me share my screen. Hold on. So quite a few of you are from China. I'm from China. And you will recognize this website. This website is very similar to Yelp. It's a Chinese version, but it has since several years ago has since entered the other markets, including the US. So, you know, don't be surprised if you see the Houston, I guess, portal of this website showing. So it's interesting. Can you guys see it? See it? Can you guys see my screen?
Yes.
Yes.
So it's showing Chinese. You may not be able to read these, but this is a CAPTCHA. This is a human, I mean, a detector. It's identifying. I mean, it's verifying that I'm a human. Asked me to do this before. So why am I not succeed? Well, I don't know why. What should I have? So I'm doing exactly that. What else do you want me to do? I don't know. But weirdly, the website, the logo is not right. But anyway, maybe just this page. It works earlier this afternoon, but not now. I don't know why. Oh, no, it works. Anyway, so this is the Chinese website, but it's been in other countries, in the Houston area. I think all these are Chinese, but these are Houston restaurants, I think. So it shows, you see Houston, it shows several more pieces of information. Again, another CAPTCHA, but I don't know how to ace. Oh, I did it. Okay. So it shows much more information that the website collects from reviewer. So reviewer has to answer these questions, and the website shows them. For rating, it has detailed rating. It doesn't only show the overall rating. You know, for Yelp, you only have an overall rating that, you know, is supposedly composed of several aspects. So this website breaks it down to flavor. This is flavor of the dish. This is the ambience or the environment. I guess it includes the hygiene and light and noise and, you know, comfort of the in-store dining experience. And service could include wait time and waitress services. Other things are similar. You have pictures, you have text reviews, you have the average price per person, I guess. Yeah, price per person and reviewers. So you know, websites can do these. And I talked about hygiene, right? Hygiene as a factor of the restaurant. There are several academic papers that look at the Yelp business context and look at these factors. Also, there's a paper about whether or not managers' responses to reviews, you know, to compliments as well as to criticisms will affect I guess, the usefulness of the review, or maybe affect the business, the business outcome. This is tourist context. This is hotels, I think, this paper. How does these affect subsequent reviews? So how are, I mean, future readers of these reviews reacting to managers' responses to the reviews? I guess, so interesting papers to check out. Besides the e-commerce, there are other contexts that will benefit from text mining. One large industry that's related to Houston is the healthcare. EMR, EHR or EMR, electronic medical records, contains large amounts of unstructured data. In a way, they are structured because they are put into fields, but it's similar to the text column thing. It's a lump sum of all the information in it, not yet, you know, able to be put into better structures. So they are kind of structured data, and there are potentially rich information that can be used to assist physicians' diagnosis of the patients. But so far, the tools are still being developed, I think. So you can check out this paper in this context. So that's motivation, why we focus on these. For today's hands-on, I mean, as well as the following weeks, we will focus on this Yelp data set, close to 15,000 rows of data and close to 10 or 12 columns, including information about the review, about the business, mostly the location of the business. These are real restaurants in Houston and Dallas areas. It's part of my research project, but I'm sharing this data with you for, you know, learning about these textual analysis. Business level, restaurant level, review level, and user level. User is the reviewer per se. Reviewer has a lead status. Reviewer has, or each review itself receives ratings, right? If you are familiar with Yelp, each review can receive ratings for funny, I guess, helpful or useful, and cool, maybe, right? Something like that. So I also collected those information about each review. But these information, I mean, these ratings about the specific review, that's the review level, will change over time. For the reviewer, I guess that's mostly information. So let me start this interactive demo. Mostly we're focusing on the regular expression, and these are the kind of dirty symbols, you know, symbols that are mostly not useful in analyzing the texts. And these are not a problem, but these are issues that come from the XML and HTML syntax. These are mostly formatting related symbols. That's why we don't need them. text mining mostly focus on the core content characters of the texts, not these formatting. We typically strip away all the formatting. And in doing those, other than the white spaces and punctuations, these are slightly more complex than those punctuations. And so that's why we need to clean them before we prepare those data by using, by tokenizing, lemmatizing, and other those standard operations. So these are what we are dealing with. And although it's a short list, it doesn't go beyond maybe 9 or 10 variations. So you potentially can simply use the exact phrase, exact symbol string to search and replace these symbols. But I like to use this opportunity to learn regular expression because these examples are simple enough to see patterns, but they involve good amount of variations to kind of discuss the scenarios, but it doesn't get too complex. Regular expression can be very complex, can be very powerful, to the level that you can't imagine for a beginner. It's good that if you have some experience, but as long as you are not an expert, you are appropriate for this content, for this part of the module. So that's a good opportunity to practice and to learn at least part of regular expression that might be commonly used to deal with data that's collected from the internet. So that's the purpose. So for the rest of the lecture, it's mostly hands-on. We can go very fast or we can go slowly. Focusing on solving problems. The focus is to solve a problem. If you take a closer look at these, this part, a lot of these looks messy, but if you know a little bit of HTML or XML, I'm not an expert. I know enough about these to deal with this kind of data for the purpose of my research. So that's mostly what I know. But also, I know about HTML. I know additional things about HTML because of writing the Jupyter Notebook Markdown cell. So I learned a few tricks in formatting them. If you know how to program HTML, you will recognize these. HTML, the basic elements of HTML is tag. Tags are formatted using the pointy parentheses. A pair of two symbols, less than and greater than, right? The pointy parentheses. And there are different names for different kinds of tags for formatting purposes. And in addition to the tags, you also have CS style embedded in the XML and HTML codes. Who here has, I guess, expert level experience with HTML? If your job is web programming, then you are an expert. Anybody? No? All right. So here, BR, and sometimes it's BR space slash within the pointy brackets. It's the new line symbol, line break, but it's not complete line break. It doesn't break out of the div tag or the span tag. It simply starts on a new line without changing the overall style, right? So in Jupyter Notebook, you can actually see the effect. Let me clear out some of these web pages. So here, let's see. Now, so that's what I was talking about, this symbol. If you put it in a markdown cell like this, it's a markdown cell, bracket BR ampersand GT greater than semicolon. If you run it, becomes a brick. It's a tag. So, you know, Jupyter Notebook is an HTML file, XML file. It uses XML formats, so it recognizes that. So very interesting. Here it doesn't recognize because it's put in a formatted. It's kind of it preserves the letters. It doesn't convert it to HTML formats. Another variation is BR space slash and ampersand greater than symbol. So that's it. So this will change a new line, as in if we do it in, but to really, this is the HTML rendering, it becomes this, but it's not effective as a new line. So if you do this, it will not change a line. To be able to change the line, you have to spell out the actual meaning of the symbol. So the HTML will work in this case. So A and B is separated by a line break. This is a line break. So these symbols gets retained in the scraped data because of the way that the scraper grabs content from the HTML source file, source code, and somehow translates the symbol that it sees. So it, somehow it becomes, messy symbols like these. This is what it sees, but in actual encoding of the characters, it becomes something like these. So it becomes a problem of the, of the analyst to deal with these. Other things are similar. The pointy, the less than A is the A tag. A tag is typically a link tag, and it has a beginning of the tag and ending of the tag, closing of the tag /A. This is a special space character. It's kind of a unique case. You can simply search and replace this, but be mindful about the escape letter here. This is escaping the X. And all of these are punctuation symbols mostly. Single quote, double quote, ampersand itself. But so you wonder why there are ampersand and amp. Amp is denoting ampersand, but why do we have an ampersand, like a sort of a double? And in this case, it's kind of a triple ampersand. Why is that? A similar reason because of encoding. If you type ampersand AMP semicolon, it gets rendered by HTML as ampersand. The code behind it is the ampersand. So the reason you have these double or triple ampersand is that inside the code, it needs to spell out ampersand to be rendered properly by another layer of XML engine. So that's why you have double that. But all of these follow some patterns, and we will analyze these patterns and use regular expression to deal with it. So that's a problem that we have. I have, you know, picked 3 example reviews. These are actual reviews data from the data set that I collected, and you can see that they have various instances of those symbol string. The first review mostly has the break, the line break symbol. This is all the 4 instances the break symbol. The second the review text has a special symbol twice, 3 times, and another special symbol. This, you can imagine, it's a apostrophe, right? Doesn't. A third example includes all of those different cases. It has breaks, it has, or it has a line break, it has the special space. It also has this is double quote. No, this is single quote, and that's the double quote. So all kinds of these problems. Well, and in the end, it has a special, a variant form of the line break. So these give you different variations of the problem. Let's deal with it. So let me run these packages first. So all of the things that I will talk about is listed here. Okay, now we have 3 texts. Before dealing with the specific issues here, I will demonstrate common uses of the regular expression. There are several ways to use regular expression package. You can compile a regular expression instance and use that object as if you have a model to access the methods of that instance, or you can directly use the regular expression package and use the methods that's offered. I find this method, you know, simple and straightforward. So I'm going to use it. It's similar to when, you know, if you want to transpose a NumPy matrix, a NumPy array, there are 2 ways to do that. You can grab that array itself, and let's say df data frame. You can use the data frame dot t transpose to transpose that matrix, or you can use numpy dot transpose or numpy dot t parentheses and give the df object to transpose. 2 ways, same effect. So same thing here. The RE is the package itself. It has functions, which is also accessible if you have a specific regular expression instance. So if you have defined an instance, you compile it, and you have a find all method there, I think. But I'm going to use the method of the package directly to make it simple. First thing I will talk about is the character set using a pair of squared parentheses. So what does it do? Anything that's inside the square bracket is a set of symbols. So, you know, you can potentially do this. It's always in a string. It's always in the string format. You can use single quote or you can use double quote. Doesn't matter. As long as you keep it consistent. I like to use single quote because I'm lazy enough to not hit the shift button. So by typing that without using the shift, it's a single quote. Inside the single quote, you have the parentheses, square brackets. Inside the square bracket, if you type a few letters, it treats, it will try to select, it will try to identify letters that are mentioned here, that are listed. But the single bracket itself stands for just one character. So by this notation, it will find A or B or C. Yeah. So, and then if you want to refer to a long list of characters and letters, I mean, and you do not want to type them all from A to Z, 26 letters, it's too long. You can use a dash to refer to a range. So it will identify letters between A and C. So following the double A, following the ASC double I character set. So potentially, if you want to refer to all the lowercase letters, you can do this, something like that. So by this, this is a pattern that you want to find in a string variable. So you use a find all function like this. You name the pattern. Pattern is a regular expression pattern. You supply the pattern, you give the string, it will find all cases that will satisfy this. This is one letter search. It searches only for one letter, and that letter can fall in all the 26 lowercase letters. So it should find U-P-E-R-M-A-N, Superman, only those lower letters, lowercase letters, and one at a time. So it becomes a list. You have everything other than the capital S, right? If you want to also find this, the capital letters, but you do not want to change, you're too lazy, you don't want to change the search pattern, then you can use a criteria here. You can say ignore cases, and it will find not only the lowercase A to Z, as well as the supercase, the uppercase A to Z. Right? So this is equivalent to doing these. This is equivalent to doing these. If you give upper letter A to lower letter Z, it was like all 26 plus 26 letters. This same thing, but I don't think you can do these. It will give you an error because it's not, A is behind capital A, so it's not a well-defined range, but you can do these, right? Same thing. And same thing here. I've already done this. Great. So that illustrates the use of the set. Don't be fooled by how many letters are inside the square bracket. You can be like this. And type, type but only letters. You can type everything in it. It's only finding one letter at a time. One letter at a time. So only S and A are mentioned here, but one character at a time. Any questions? No? Okay, so it's time to talk about the caret symbol. The caret symbol is mostly useful together with a set. Caret means anything other than those that are mentioned. So if you use a caret inside the square bracket, it has to be the first symbol inside the square bracket. Otherwise, it will become part of the letters to be searched for. It will lose a special meaning. The caret set has a special meaning you use it at the beginning of the inside of the square bracket, it becomes, its meaning is the other, I mean, the complement set, the set of symbols that are not these. So what does this mean? The complement of lowercase a to z, it's not the complement of a, but the complement of everything that's included in the square bracket. So what does this mean then? Caret lowercase a to z, what is it looking for? What is this pattern looking for? Any volunteers?
Everything that's not in lowercase a to z.
Like what? Can you give some examples?
From this word,
Anything, potentially anything.
uppercase A, uppercase B, uppercase C.
Until uppercase Z.
Z, yeah.
Anything else?
Or maybe even numbers.
Yeah, numbers and punctuations, everything else.
Yeah,
I mean, everything else. That's literally everything else. Right. So, you know, we can change these. Superman, and we found uppercase S and the exclamation symbol. Right. So that's the utility of the caret. If we do, what if we do ignore cases? So the complement of the lowercase a to z, and by ignoring cases, it also excludes the capital letters a to z. So it's ignoring the cases of these named examples. So in a way, it's like these. In a way, by using ignore cases, you also included the capital letters in the set to be excluded, right? So by excluding all these, then by searching Superman, it won't find anything. It will be an empty set. So keep in mind that these are list notation. The brackets are not inside the quotes. So these are the list notations, and there's nothing in the list, so it's empty list. By slightly modifying the string to include a symbol, I mean to include a punctuation, then you will find one result. You'll find the exclamation symbol. This will have the same empty set result. That make sense? Okay, moving on. Escape letter, escape symbols. Escape symbols are useful because when sometimes you want to find the symbols that have a special meaning. You know, an example would be the square bracket. Square bracket it has the meaning of a set. What if you want us to find the square bracket? You know, such as this. You have a sentence and you want to search for the square bracket symbol. Then you need to use the escape symbol. I think, you know, the purpose is straightforward. To find the square bracket here, but to find them as a pair, you would have to include the set of symbols exactly as they show in the string. So there is a space inside, so you need to type a space between them and use escape symbol to escape the two special symbols. And you can find that. So this is a list with one element. The element is a string. Within the quotation, it's the string with three symbols, the square brackets, as well as the space. That's how you find it. If you remove the space there, it will try to find a pair of square bracket with nothing inside. It will not find anything. And this is not something that's found. This is an empty list, just to make sure, right? And because there is no square bracket with nothing in it, it only has a pair of square bracket with a space in it. So it cannot find something like this. Change it back, you can find the symbol. That makes sense? Okay, now escape symbol. So all of the bracket symbols have special meanings. Square bracket has a special purpose too, which I won't talk about here. It's a little bit more advanced. You know, it's more about a group of sets within some more complex regular expression. It's too complicated. So to find the parentheses, to find the left parenthesis, you will escape that. You will find the left parenthesis. You know, all the brackets will need to be escaped to be found. Any questions? Straightforward. So let's do some little more advanced stuff. Using the same example, square brackets are mainly used to enclose words added by someone other than the original speaker, and you have a pair of parentheses. You want to use a regular expression to extract the pair of parentheses as well as everything inside. So take out the entire portion. You want to find the entire portion. This is a little bit advanced. So you need to consider what is inside the square, the pair of parentheses, and you need to, you know, what kind of characters are inside. You need to use special sets to find them, as well as you need to be mindful about how many letters are inside. You cannot hard code it because it won't work. You cannot anticipate all the scenarios. So you would need to use some special symbol here. So several tools put together. First, let's try this. Will this work? A pair of parentheses, I use escape for that, and I have square bracket to refer a set. This set could include any letter and any number. Will this work? Will this be able to select this portion entirely? Anybody? Yes or no? Yes? No?
I don't think so.
What do you think it will select?
I can see that we are not selecting special characters like comma and spaces.
Oh, comma and spaces. That's a good point. So what could this select if it's inside the string? So I said that this part is only going to select one and only one character. That can be anything inside this set, right? So potentially it's trying to select something like I don't know, it's trying to select something like parentheses A. If there's an instance in the string that's the same as this, it will be selected, right? Or it can be any letter. It can be any number, right? But there is none of these cases, right? There's only one pair of parentheses, and there are many letters inside. So there's no instance where there's only one letter. So this will return empty. Nothing found. So the solution, trying to find the solution. The solution is to use a special symbol. The special symbol allows the set, any of these instances, to be repeated for X number of times. So that's the trick. And instead of typing A to Z 0 to 9, an equivalent special equivalent way to do that is to \W. \W is referring to alphanumeric letters, exactly as referred to here. It's the A to Z 0 to 9, as well as an underscore, but that's a minor difference. It's mostly the alphanumeric letters. So here, \W is referring to capital A to capital Z, lower a to lower z, and an underscore. I think that's the case, right? So you can use that, but Soya noted that there are spaces that need to be identified, and this set doesn't include space. So white spaces is another set that will include the space and other spaces like non-break symbol, like something like here. This is non-breaking space. It's part of the white space. It will be identified by the \S. So by including the spaces, but also we need a comma, right? So later, by including the white spaces, at least it includes all the spaces. So spaces need to be, be cognizant about that, and use asteroid. Asteroid allows anything in the set to be repeated for asteroid to be repeated for 0 to infinite amount of times. So 0 and plus, 0 or 1 plus. So by using an asteroid, what it can find is parentheses, nothing else. It can find something like that. If there's a pair of parentheses with nothing inside, it will find it. And parentheses with one letter or one number or one white space, it can find, or potentially parentheses with many letters, space, and numbers. It can find these. It will, so the asteroid symbol is very powerful. It can potentially select a very long string, sometimes to over select symbols that you don't want to be selected. So be careful when you use that. Other variations of the special symbol include plus. Plus means 1 or more than 1 times. So it excludes 0. Otherwise, it's the same. And a question mark. Question mark means 0 or 1 times, exactly 0 or 1 times, but not more than 2 times. So the 3 variations to your disposal. So this, it doesn't have the comma So obviously it won't work. It will select an empty set, but once you include a comma, it will select the entire portion of the string to be found, right? So this is the trick with the symbols. Special symbols need punctuations. Typically, there's no special set for that, so you need to include everything that you can anticipate here in the set, along with the other special sets. But there are only perhaps 12 symbols, 12 different symbols that you can, or maybe 15 symbols you can imagine. Some of them needs escape. So, you know, pay attention to that. And otherwise, it's good. So maybe you want to remove the parentheses, but you have to include the parentheses in order to find them. Otherwise, if you don't have a stopping point on both ends, it's hard to identify. It's hard to find any other pattern that can identify this portion. But you can get rid of the parentheses after you have found this portion of the text by using, you know, slicing function, right? And this index 0 is to refer to the only element in that list result that's returned. So this is critical. After that, you are dealing with a string. With that string, you can use slice to only extract those letters, or potentially you can use another regular expression to find only those letters. But this is a more convenient solution, I guess. Any questions so far? We have talked about escape. We've talked about sets by using square brackets. We've talked about special symbols to repeat a potential set of symbols for X number of times. Any questions? To practice the character set, this is alphanumeric set, includes the characters and the numbers. Oh, I forget to do this. It also includes between 0 to 9 numbers, so it's alphanumeric. So if I have this string, mix of alphabeticals, these are alphabeticals, and symbols, these are mostly punctuations. And I use the alphanumeric set within a pair, within the character set, it will find single characters from this long string that satisfy this condition. So it will find almost everything other than the spaces, right? And it will be a long list. It's finding every letter, every punctuations, and separate them into element each, and put them into a list. But for these character sets, we have \W, \D, and \S. If you use a capital letter version of it, it is referring to the complement of that set. So using capital W means to select everything, anything of length 1, to select anything that's not in the alphanumeric set. So what are the characters that are outside the alphanumeric set in this string? There's only one thing here, or one kind of thing here. What is it? Or maybe more than one kind, I think. Yeah. Right. This, yeah. \W is only for alphanumeric, so punctuations are not selected, but except for the underscore. So this part, using the complement of alphanumeric set, is selecting those symbols as well as the spaces of all the spaces and the symbols other than the underscore. So this is equivalent to using this. This is very equivalent, other than, you know, the complement of lowercase w escaped, but you need to include the space to be to exclude in hold on, right? No, this is to get rid of the space, right? How to get rid of the space? You add the space into the complement set. So here, there's no way to easily exclude the space. So you need to use the complement of the complement, you know, in order to exclude the space. So by this way, you only extract those punctuations except for the underscore. Hopefully this makes sense. And special symbols here, another exercise. So we have a, you know, sort of a list of superheroes here, and we have number sequences for them. I want to use regular extraction to extract those numbers as well as the parentheses. And notice that there is a parentheses, there's a pair of parentheses that doesn't have anything inside. That presents some challenge here. But so let's see, does this work? I want to select all the parentheses with numbers or with number or without number in it. And there are different widths of letters inside the parentheses. Will this work? \D is the digits. So escape parentheses, a pair of parentheses. Inside, I have the digits, set of digits. So this will only select width of 1. It will only select those parentheses that has only one letter, one number inside, not more, not less. So it will only select 1, 2, 3, and 4. That's it. Together with the parentheses. So to be able to select those cases where there are more than one, then you can use asteroid to repeat X number of times until it detects the end parentheses, right? So by adding an asteroid, you can potentially find the, let's see, you can potentially find these two as well, right? So empty parentheses and parentheses with 100. What if you use a question mark? What are being selected and what are not being selected? Question mark refers to 0 to 1 times. So 0 width or 1 width of 1, but not beyond a width of 1. So what is being excluded?
1.
1?
Oh,
This one?
I think so. I guess so.
But
not include 1. Oh.
Right. So, or what will this find? Digit set and 0 or 1 times repeated. Any letter, I mean any digit, repeated for 0 or 1 time. So, which of these will be selected and which will not be selected?
Except 100.
Except 100, yes. So the 100 is exceeding the width limit, right? The question mark only limits to 0 or 1 digit. So, right, the 100 is excluded. And what about in this case? If we use a plus sign, plus means 1 or beyond, 1 time, at least 1 time, and beyond. It will exclude one of these.
exclude the no,
The empty.
just the parentheses.
Yeah, the empty parentheses.
Yeah.
So all the letters. Yeah. So by this exercise, you kind of see the differences. Good. It's quite interesting, right? This thing is very powerful. Later you'll see. And it's, you know, it's clear when you are dealing with, you know, one example at a time. When you're dealing with a long column of text and with all kinds of possibilities, and you don't know the entire set of scenarios, the job kind of become daunting. But we'll talk about those. Once you have a pattern, so these are patterns, right? The pattern that you provide to the find all function to search in the string. Once you have constructed a pattern that works, that you have tested, then you can use the sub function to replace that with anything you want. I typically recommend to replace with space. At least use one space. Avoid replacing with an empty string, which means only taking those symbol sets away without replacing anything. Adding space is good, even if it's redundant, because later it's very easy to get rid of the spaces. It's hard if you accidentally combine two words together. You kind of created a new word that's impossible to separate them if you didn't detect that. Okay, so the same example here. I want to replace, so I'm using this pattern. This pattern is getting a lot more complex as you look at it. So it finds an infinite repetition of characters that are either letters or white spaces or a comma sign. So it's basically finding this portion of the string. It will replace it with a space. And so let's print the original version and let's print the replaced version. We can see the difference. Up until this point, it's the same. This portion is replaced with a space. You will have 3 spaces remaining, and the rest of the sentence will be preserved. So that's what it does. So now let's work on the specific examples. Let me print the 3 example here. When you print the strings, the output will not, could possibly break the word. You know, it's not formatting properly in terms of creating appropriate line breaks. So, you know, A and D is a word, but it's broken. But anyway, you get the idea. Let's deal with these different kinds of problems. So the first problem to deal with is this line break. It could be this or in this format. So even if you can search for this literally, you know, use escape to escape the ampersand and replace it, but it's a good exercise to use regular expression to find to include other variations like these, right? So let's see. There's a pattern here. I define the pattern and I use a pattern variable in the find all function to make it easier. So will this work? Take a look. So what it does is basically use a less than symbol. This one doesn't need to be escaped. Less than symbol. Wait, does it have to be escaped? Yeah, pointy brackets doesn't have to be escaped. So less than symbol and a symbol set that can be repeated 1 or more times and followed by GT greater than and semicolon. So it can find this beginning portion and GT semicolon and some set of symbols, ampersand, as well as alphanumeric letters to be repeated one or more times. This one can definitely find this case. Can it find this? A variation of the line break. Example 3 has both this variation as well as the normal case. So it can definitely find these. Can it find this variation? What do you think? This pattern.
No,
And
it can't.
I'm using ignore cases, so it could potentially find the uppercase GT. So, Soria?
I don't think so it can find it, so because it has got space, the last one.
Yeah, the space is the tricky part. So it finds all the traditional, the typical case, but it couldn't find the one with the space and slash, right? Slash is another symbol that needs to be considered. So an improvement here is to include, all the alphanumeric and the symbol ampersand and the symbol and the white spaces and the symbol slash itself. So using this version, you identify the variation. So typing all of these it's getting long. What if there may be another symbol that is not considered? That's, if you need to look at all the examples, and it's kind of very time consuming. Is there a way to use the caret to do the same? At least, be able to select all of these as well as potentially other variations that might have other symbols, beyond the ampersand and I guess the slash. Maybe there's an exclamation. It's not likely in the space of HTML symbols, but what if there is? So let's practice that. How to use a caret. So at least I will first type the same pattern, beginning and ending part, and as well as at least one or more repetition of something. But this time I'm going to use the caret. I want to consider scenarios that are possible, but I want to exclude symbols. I want to avoid putting in symbol here that's very unlikely. So by using the complement, I only include symbols that are impossible to appear between the beginning and the end. So what would be, this kind of requires a little bit knowledge about HTML. Because HTML symbol is mostly the tags, and the symbol to indicate tag is the less than. So here I would only put less than. So what does this mean then? The pattern begins with less than, and it ends with greater than. So it's a beginning and end. I'm saying it could have anything it wants, except for another beginning symbol, which is a less than. Because if there is another less than, then it's definitely not a HTML tag. It could be something. It could be, maybe double less than that is referred to by the user as part of the review. It may be generic content. It's not a tag anymore. So, this is how I would do it. Anything else that you think is highly unlikely in HTML tag that would appear between the beginning and the end, you can put it here. Otherwise, you will restrict yourself from including anything else, because anything else that you put in here, if it appear in the portion of the text that you want to identify, this pattern will prevent it from being identified, right? So, this part requires more thinking. Let's do this. So by using this pattern, you can find everything that's found here, and also potential other variations. So I think this is a reasonable improvement, and it's more cleaner. It's cleaner than the earlier version. It's more general. It's always finding a balance between being the most general and being over general, or over select generic contents. And I will show some examples later on. So using this, you can replace the instances in text3, all these symbols, with the space. So I'm using the regular expression .sub to replace everything in text3 and print the replaced version. And let's compare the version before and after the replacement. You can look specifically. The break symbol is gone. By far is advanced here, two spaces. And other breakpoints gone, and the trailing line break is gone, replaced with a space. So that part has been successful. So we end up with a new version of text3, and we will keep using this to solve the other problems. So the second issue is this special symbol. And for this, you don't need a specific pattern. You use a pattern because we'll keep using the regular expression, but this is a simple pattern. It's a literal string, so we don't need any set. But the only thing to keep in mind is that the backslash symbol needs to be escaped, because itself has a special meaning. It's backslash, but we want to find the backslash. We use double backslash. The first backslash will escape the second backslash. Right. So if I use this pattern to find all, then I will find a list, and when I print the list, it will show. But something interesting that you will notice in here, I use display, and you can find the special symbols. But when I print them in the third text, you don't find it. That's pretty interesting. So the special symbol will not render when you print, or the special symbol will render when you print. You can't see the source code, but when you display it, you can see the source code. When you print it, it's hidden. It's rendered. It's space. So it becomes a space without showing the codes. So that's pretty interesting. So here, if I do these, if I print the entire string, it will print it because it's a source code. But when I print each of the element, like these, for each of the element string in the returned search result, I print each element, I get a bunch of spaces. It's rendered, it doesn't show, it's invisible. But you know that it's there because it takes several rows. So, to see that, you would have to display it or simply return as outcome. So by using this pattern, you can replace it with space. And this time I didn't print, but it's also gone. So things like somewhere here, they are not there. It's being replaced. So we get a new string, text3_2. Keep working on it. Any questions? This part is quite straightforward. Okay, now the remaining symbols all have this pattern: ampersand, AMP, semicolon, pound with some additional digits, and always ending with a semicolon. Other variations might not have the digits. They might have, other variations may also not have the pound symbol. So, you know, we need to find a pattern that can find all of these instances. But it's doable. It's not like it's something impossible. So I've come up with two patterns. One is more specific. The other is more general. I can spell out the entire portion of the ampersand symbol and ampersand part because every one of these variations have that, right? So this part is to be searched literally. And there's always an ending semicolon. So I put that as the boundary. So between the two boundaries, I have things that changes. I sometimes have letters. I always have some letters. Not really. In these cases, there's no letters. In these cases, there are only letters. So I could have letters, digits, and certain symbols. So that's one way. Or if I want to be more general, sometimes I may have, you know, just maybe, I don't know, ampersand, but something like these. And I don't know what that is, just, you know, trying to be creative. And so if I want to find something like that, then I don't want to put the AMP semicolon in the literal string, but try to include that in the pattern, but the end boundary is the same. So let's see if that will work. If I put these using the first pattern, I spell out the AMP and I put the letter, the alphanumeric set, as well as that will take care of the letters and digits. I also include a bunch of symbols. The pound has been observed. And what else? Is this sufficient? And I can repeat possibly one or more times, as is apparent here. Repeat it 3 times, 3 times, 3 times, and 4 times. Will this work? Will this identify from text 2? Text 2 example is here. It has ampersand pound 39. I guess only one instances, but much more instances in text 3. It's 39 and 34. What else? It doesn't have the ampersand, but yeah. So will this work for text 2 to find that one instance of 39?
Yes.
Yeah?
Yeah.
It should work because it does have the pound, the numbers, and both ampersand is in the literal. It will work. Okay. For pattern for the text 3 after the 2 changes, so it's here. Will this work to find all the instances? Let's see. So take a closer look. It does find all 4 instances, but it somehow selected the favorite, which is supposed to be retained. So it began from this part and is selected all the way until the end of the second 34. So let's kind of take a look. This pattern has has the condition of the beginning portion and the end portion it has to satisfy. And this part, let me take over and observe. So for this part, it specifies the beginning and the ending part. Instead of taking this semicolon, it take this semicolon. And everything inside the two boundaries satisfy the set here. Repeat it one or more times. All the alphanumeric digits, alphanumeric. Let's see. Not this one, sorry. This, yeah, hold on. So, between these two, alphanumeric, pound, it did not have semicolon, but somehow it selected semicolon, right? The pattern doesn't have semicolon, at least in the repeated portion, it did not have semicolon, but somehow the regular expression found or included the semicolon in it. In the portion that can be repeated. Quite interesting. Do you see it differently?
Yeah, and not even once, it selected it twice.
What do you mean?
I mean, there is semicolon before F and after AMP. So it's being repeated twice.
Right. The semicolon is allowed to be repeated, selected by this part of the pattern, right? Something I've found that makes an impact is that, let's say, let's make sure it produces the same result. Something I found that the ignore cases made some dramatic change effects on the symbols. So if I remove these, if I keep it, what does it mean? I allow the alphanumeric sets to also consider the uppercases, and I also allow AMP to consider the uppercases, but I would not expect all the letters, all the punctuations to extend to uppercases, because there's no uppercase in those cases. They are special punctuations. But if I remove this, let's see, I still find it. So to me, I'm a little lost on why the semicolon is also selected by this pattern. I need to spend more time on this. Any other questions? But anyway, in any case, using this pattern is over broad, is over general. It selected something that is not supposed to be selected. So we need to find a way to prevent that to happen. Yeah. Any questions before I move on? So anyway, besides that, it selected these. So how to prevent these? The trick is to analyze what characters that you are sure definitely will not be included, and then use a caret to offset that. So all these can be included, that's fine. And if you identify a symbol that definitely should not appear before the end of it, and which is also causing problem, or which also appears here in the generic letters, or let's see, not the generic letter. As part of this, that can help you set the boundary before that symbol, and that's the case. So it's the same mindset with earlier that I used the caret symbol to exclude the possible appearance. So let's deal with this. So the purpose is to only select until end of the 34. Do not select these. So potentially, I can identify a symbol in here that when it detects it, it either is indicating generic character, generic content, or it's indicating another appearance of the same pattern. So, you find that this symbol is indicating another instance of the same pattern, right? So you can specifically exclude this symbol to prevent the regular expression pattern to select over this symbol. It's currently selecting over this symbol, and it ends here. If we exclude this, and which means we do not allow the ampersand to appear between the beginning and the end, it will be effectively cut, at least to this point. And the regular expression will try to find another semicolon before this, and it will find this to be, to satisfy the condition. So that's the pattern that is an improvement. Everything else is the same. So I'm setting the complement of the ampersand. Anything else can do, right? And let's see if it works. So it's kind of a disaster. It didn't work. And it's even worse. It selected not only these, hold on. Where's the favorite? Oh, the favorite is, hold on. Right, the favorite is actually resolved. So this portion has two symbol strings, and this solution does recognize the first part, and it didn't include the favorite, but it somehow include a long string in the second instance. So let's analyze this. How come it's selecting all the way until here? So the issue here is that by specifying the complement of ampersand, it does successfully solve this problem. But it didn't anticipate another problem, is that in the texts, let's see. So in the texts, in the generic content, users will also use semicolon. So one feature of these special symbol is that it's what's the name of that? It's greedy. These symbols are very powerful and very greedy. What does it mean? It will try to select as much characters as possible, as long as it doesn't violate the patterns that you specify. So potentially, it will go all the way to the end of the document and try to select as much as possible, as long as it doesn't violate the rule. So let's see if that violates any rule. Beginning portion end portion is semicolon, and everything between them, as long as it's not ampersand, it will be selected. So that's the case. You know, in this entire long string, there's no ampersand, but it's selected. I mean, it doesn't have ampersand, so everything will be selected, but that's not the purpose. Our intention is to only select up until this portion. So is there a character that you can identify that will effectively solve this problem? We can put this into the set, and to use a complement, that means whenever, you know, the regular expression found that character, it will place a boundary over there to not select over that symbol. Is there a symbol that you can, that you think you should include? So let's improve it. This is pattern 3, the same pattern 3, and we will implement an improvement here to add something into the set to exclude it from the repetitions. That should cut the selected portion short until here. So which character should we include?
AMP again?
AMP?
Yeah.
AMP is already included, but it didn't work.
I mean, what if we complement AMP again?
This is complementing AMP,
Oh.
right? But there's no AMP here, so it's got to be a different symbol.
A period.
A period, like this. Period, let's see, what does it do? Yeah, a period does it. So what does a period do? Let's analyze that using this example. So the difference between these two is that the program will first identify the beginning and identify the ending symbol or literal as farther away as possible. So that's the end of it. That's almost that. I think that's the end of the sentence, or that's at least that's the last semicolon that it can find in that string. And it tries to see the pattern to try to evaluate if the portion between these will satisfy the pattern. If it doesn't, it will move its place. It will advance the boundary to earlier and evaluate again. So this is what the program does. If we leave it like this, it doesn't find anything that violates this pattern, it will satisfy. But here with period, it selects this entire portion and see if there's any period or any ampersand that's inside it. It does found some period. It found 1, 2, 3 period. And because any period will break the rule, it will reduce the boundary up until this very first period, because that's the only way to satisfy the pattern, right? And here it still has to satisfy the ending symbol pattern, so it further advanced the boundary to this symbol, and in the end it selected only these as the repeated pattern, and this portion doesn't violate this rule, so it selected it. So nice job, I think Melanie, right? Nice job, but I like to caution that is period the best option. Period may happen here. Think of another scenario where the person didn't use period at all. Then you will face a similar situation, but this solution will not be helpful entirely, right? So could there be a better solution? This is very good in the current case, but if, let's see.
Can we use a space?
Huh?
Is it possible to use a space?
Space,
Space?
yeah, space should work too. Space works too, but again, space is, I think space is better because in a generic content, space is 99.99% likely to be used, much more likely to be used than period. That's obviously a better option. And another thing to think is that, does HTML code include the space as part of its, tag? Based on the variations that we see here, it's not. The HTML symbols are quite compact. It doesn't include a space in between. So space is a much better, I mean, period is very good. Space is a much better solution, right? So we'll leave it as is. So space will work in here. So using this pattern, we will, use the same search rule to replace this pattern with space, single space, and let's see. And based on the version 2 of the text 3, let's see. Somehow it's still included. And this is the part similar to the previous, and it should successfully separate these two symbol strings, but it didn't. It left. I mean, it still left the symbols, and it didn't take away everything, which is even worse. But it left the symbols unchanged. So I somehow stumble on this solution that if I remove the ignore cases, it will work. So let's take a look. If I remove the ignore cases, it does successfully recognize both part of the symbol strings, and it does remove them and without removing the favorite. So the best solution is here. The takeaway, I guess, when you have symbols that are tightly connected with generic letters without having spaces in between, this could be a problem. So a quick test would be that in one of the original texts, if I include some spaces here, will it not create so much of a problem? I need to run it first. So if that's the case, and do the first thing first, do this. It removes the breaks, and next thing is to remove the special space symbol. Just remove that, and let's see if it will create a problem here. So use this version, see if these two will be removed. It didn't. So somehow the ignore cases is creating some kind of issue here. But again, if I use this version, it's successful, and you see additional space here. That's the space I added. So there's still some lingering issues to be resolved, but the bulk of it is good by using a workaround to remove the ignore cases. So that's it. That's what I planned for today. I hope this interactive session is interesting and helpful for regular question. For me, for this course, you don't have to know much beyond what I talked about today. And I'll post videos to sort of explain these use cases in the broader context of the Yelp data. So that's a much larger data set. It's more than 3 reviews. So there are other situations there. Some of them include things mentioned here. So in that bigger data set, how will these code work? Is there better versions of the code that can deal with these issues more better? Maybe. So I'll make some videos, and there are some questions related to those in the homework. So review those videos, and I'll post them likely this week. Other than that, any other questions? So next week we will, I will talk about how the Yelp data is collected. And let me stop share here. I'll talk about how Yelp data was collected at a high level. If you're interested in learning how to collect data from sophisticated website, I have some tips to share. I'll talk about preparing the textual data, tokenizing, lemmatizing, and a few tricks. And in the end, how to put them all together and do it conveniently by using a pipeline. Then the third class will focus on the topic modeling, how to understand the model. What does the model do? How to see the model working, and the utility of the model, as well as how to evaluate the performance of the model. So that's the following 2 weeks. Okay, we'll leave the rest of the time for questions. Feel free to leave. See you next week.
Bye.
Questions?
I have a question, Professor.
Yeah.
What was strange was I was just playing around and I complimented AMP and it worked.
Which part?
The pattern, the last part in the pattern tree.
The last part.
Yeah, I don't understand why, sir. I was just playing around. I was just putting.
Yeah. So what happened?
It worked. I mean, it just gave the same output as the same output where I would complement and period and space.
Period. And
in the class we tried complementing and period, right, sir?
Maybe you can share your screen.
Yes, sir. Yeah.
Yeah, go ahead.
So similarly, I tried complementing AMP and it worked, sir. Can you see the notebook, sir?
Yes, but it's quite small.
Oh, I don't know. I'll do it again, sir.
Let's see.
Yep.
Okay, great. Thanks.
Yes, sir. I tried complementing the letters AMP here, and
okay, yeah,
it seems to be working.
But okay, so you know that when you use the complement like that, it will not treat the AMP as a group of letters, but it will complement A and M and P all together.
Right.
In any order, right? So that's a grouping function that must be there. Maybe that's these small parentheses, but I'm not sure entirely. You can check the regular question website.
Yes.
So yeah, this is the way we use, but I still don't understand why the ignore cases will cause that problem.
Yes, even I don't understand that. That's
yeah. So and something also bizarre earlier, right? I mean, in one of the earlier examples, I didn't put the semicolon into the set. that can be repeated, but the pattern somehow found the semicolon twice, including the favorite part, favorite
Yes.
word. So why is that? I don't know. A regular expression is it's a beast, I think.
Yes, sir. That is
A
true.
monster.
One more thing was, sir, I was going through PML and the textbook suggested regular expression is really a beast. It has got a really steep learning curve.
Yeah.
So they have suggested to use Python's HTML parser module.
Python's XML. Okay. That suggestion is good for those so complete tags, those tags that are not broken because of encoding. And the problems that we're dealing with are because of encoding. I don't think the XML, as well as some other packages that they use extensively, Beautiful Soup, right, is for navigating the HTML trees. If the codes are complete HTML codes, then those libraries will be helpful. These are the remaining problems of the codes that have already used the packages. So these are not useful.
Got it.
Yeah. But maybe using these examples to learn regular expression is good. But I guess the only downside is that you can use simple workarounds to deal with these problems, because there are few variations here, right?
Right.
So you can use literals to deal with all of these problems. So regular expression kind of become an overkill in this case.
Yeah, sometimes
it's interesting practice.
Right, but I also felt sometimes if you're dealing with really big sentences and a regular expression, sir, a simple mistake, we might be losing a lot of words without, we won't even be able to notice that we are losing the words.
Right. So that's why, carefully verify the search results will be very critical. And other than the discoveries today, I will be very confident. But seeing that even when the pattern was found but not replaced, leaves me some doubt. But I do have some tools, or I guess tricks to verify. So in a very long document, it's kind of daunting to see all the possibilities. But by using NumPy, not NumPy, by using pandas data frames, you can quickly analyze what are the possibilities, and you can see all the possibilities very quickly. Especially if you have done a very good job in terms of constructing the pattern, and the pattern only misses a few things. So maybe it over-selected some letters in some cases, and you only want to see what are those cases. Using pandas provides a very good ways to do that. I will demonstrate in the video, and you will see.
Right, sir.
Yeah. So it's possible to make good use of regular expressions, especially in dealing with the data that are scraped from website. Yeah, but regular expression, in the past, when I have problem with dealing textual data, when I search around for solutions, always come across solutions that are in regular expression terms. But because this part, I'm scared to touch, I cannot access those solutions or those suggestions. So I guess whenever I can, I will try to understand regular expression better, right? As much as I can, but not overkill myself. So I guess a little bit of understanding will help. And over time, you'll pick up more. I will pick up more. So it's kind of, Rome is not built in one day, in one night, but over time you'll grow.
True, sir.
Yeah. All right.
Right, sir.
So I guess that's it. So
Yes,
good
sir.
night.
There's one more thing, sir.
Yes.
I've emailed you about something.
Right, I saw that, but I have too many emails to reply.
Yes, sir, sure.
I'll get to that.
Sure, sir.
Or maybe we can talk about it now. So you
Yeah.
asked about courses, right?
Yes, sir. Courses and
And you're in the capstone practice, right?
not yet, sir. I think
Oh,
I'll be,
you're not, okay. So you will enroll in that next semester. Other than the 6, but it's a two course series.
yes, sir.
So you'll enroll 3 credits first. The letter, the course number is going to be different. You'll search for BZAN6357. It
Sure,
will
sir.
say Capstone Capstone Project 1. So you will request for us to approve. This needs approval. You can request it from Miss Newman, Marion.
Sure, sir.
Yeah, and she can do that. I will communicate with her on how to who to approve and who not to approve. Make sure you request for the number 1.
Sure, sir.
Other than that, how many credits do you need?
I thought I'll be taking 3 more courses next semester. I'm currently I'm in my 2nd semester.
Yeah, you'll miss.
Yeah, currently I'm in my 2nd semester, sir. Next
Oh,
semester.
you're 2nd. Okay.
Yeah.
Yeah.
So maybe next semester I'll be taking another 3.
Right. You want to be so if you only have 9 credits left, you wouldn't be able to finish all of them. You can finish 6, and because the capstone is 2 course series that has to be taken 2 semesters. If you need any recommendation in terms of electives, let me know.
Yes, sir. I think I need 18 more courses, 18 more
Oh, yeah, 18
credits.
more. Okay,
Yeah.
so you'll take 9 or 12.
Yeah.
It's up to you. So 3 for capstone practicum,
Yeah.
and 6 for the electives, I guess.
Yeah. Yes, sir. So one elective, I want to take a research study on a user. I want to continue.
Oh, right. You mentioned that. I don't know how that works. I know how that works for undergrads, but I don't know for grad students, how does it work? As far as, I think my hands are tight next semester. It's possible to go with other faculties, but I can ask around and see. First, I need to understand how that works first, because I haven't done it before.
Sure, sir. Yeah.
Yeah. Other than that, do you need any recommendation for electives?
No, sir. The primary concern was asking you about the research study.
Okay. Yeah, let me take a look. Have you heard anything from folks that have experience with this?
No, sir. All I know is that you can take a research study course under a professor, and that is all I know, sir. I don't have any other knowledge because all the people I know of they simply took electives and then finish them on. They didn't go this way.
Yeah. I know university program about Sure. I was trying to promote it in undergrads. I know, but I'm not sure if it can be used for graduate students.
Oh.
Are you sure that part?
I'm not. Yes, sir. I'm sure because maybe I'll try emailing Marian Newman about this.
Okay.
I'll let you know. It's just that I love this subject so much. I want to explore. I felt it's machine learning is incomplete without learning about.
Mm-hmm. So there's other possibilities. I know a few professors in the Hewlett-Packard Institute.
Okay, sir.
And they do applied machine learning research extensively. So I guess you can, for them, they can see it as a benefit. Your work can kind of contribute to their work. And they also, I think they could use some help. And in the meantime, you can learn. So I think that we will approve that course if they are willing to do that. So, email Marian and find out. In the meantime, I'll think about who I can reach out to.
Sure, sir.
Okay. Sounds good. All right. Have a good night.
Thank you, sir.
Bye.